Okay, here we are, Chapter 9, Section 1, Multiplying and Dividing Rational Expressions. Starts on page 463 of your book. Here we start out with a rational expression is a ratio of two polynomial expressions. Remember that a ratio is a division. Okay? So whenever we're like, okay, there's 7 boys to 9 girls, it's a ratio. It's a comparison of two things, and it is done with a division sign. Okay? So that's what a ratio is. We just do a divide, and we do it like a fraction. Because variables, in algebra often represent real numbers, operations with rational numbers and rational expressions are similar. For example, when you write a fraction in simplest form, you divide the numerator and the denominator by the greatest common factor, the GCF, that we can see there. So when we have something like 35 over 40, 35 can be rewritten as 5 times 7, 40 can be written as 5 times 8. Anything divided by itself reduces technically to 1, and then 1 times anything is itself, so we reduce to 7/8. You can use the same process to do rational expressions. So that same math that we do with fractions, we can do with more complex fractions that have expressions in the tops and in the bottoms. So here we have a quadratic equation, x squared plus 7x plus 10. It factors to be, we get our two parentheses, each one gets an x. We can see that there. And then factors of 10 that add to be positive 7 are 2 times 5. 2 times 5 makes 10. 5 plus 2 makes 7. They're both positive. And then we look on the bottom. Each one gets an x. Factors of 6 that subtract to be a negative 1. Well, you got 1 and 6, which subtract to be 5, so it's not that. You got 2 and 3, which subtract to be a 1. And those are the only factors of 6. Now we need them in the right order, so we put our 3 and our 2 in. We need negatives on the inside, so we want the 3, the bigger number, to get the negative, and the 2 doesn't. Now, if they have a common factor, a whole expression can be a common factor. They both have an x plus 2 multiplying, so we can cancel that out, and that leaves us with x plus 5 over x minus 3. Sometimes you can also factor out a negative 1 in the numerator or the denominator to help simplify the rational expression. And we'll get to that whenever we see that happen. Okay. Now, let's look at example 1. Simplify a rational expression. Simplify x squared minus 2x minus 24 over 2x to the third plus 6x squared minus 8x. And state when the original expression is undefined. That's very helpful. Okay. So if you need to pause it, write all that down, and then we are going to start with the problem. So, example 1. We got x squared minus 2x minus 24 over 2x to the third plus 6x squared minus 8x. And we're going to factor them apart. The top one is a quadratic. Always, first, look for the GCF. So x squared, 2x, and 24 don't have anything in common. So I can go to my parentheses. Each one gets an x. That's because x times x makes x squared. So factors of x squared that make, that turn into x is x times x. So each one gets an x. Now we do factors of 24. So you got 1 and 24. You got 2 and 12. You got 3 and 8. You got 4 and 6. And 5 doesn't go, and we're back to 6. So those are my sets. Which set of these does this to make that? Well, I need to subtract to be 2. 1 minus 24 would be a 23. 12 minus 2 would be 10. 8 minus 3 is 5. 6 minus 4 is 2. So I got 6, and I got a 4. I need it to be negative, so I'm going to put it with the 6, because different signs, this one in the back means they're going to be different signs. This sign goes with the bigger factor. And that'll be negative 2 leftovers. Now, in the bottom, they all have at least one x. So I'm going to pull that out. And that would be, now if I did x, that'd be 2x squared plus 6x minus 8. Not only did they all have that, they all had a 2. So I can do x squared plus 3x minus 4. That makes it a little easier to factor. So I'm going to pull out my 2x, and then I'm going to do my 2 parentheses. Each one gets an x. Factors of 4 that subtract a 3. We got 1 times 4, and we got 2 times 2. Well, 2 minus 2 is 0, so that's not it. 1 minus 4 is 3, so we're going to do the 4 and the 1. The 3 in the middle is a positive, so we put a plus with the big number and make that one a minus. Okay, now we factored our pieces, the top and the bottom. Now we look for common pieces. Well, I see x minus 4s, so those get to cancel out. And I got an x minus 1 and x minus 6. Those aren't the same, so they don't cancel. I got a 2x, so that doesn't cancel. So I've got x minus 6 over 2x times x minus 1. Okay. Now, we need to state when the original was undefined. Now, remember, there's some places where we have to worry about x. Okay, domain issues. Domain is your x value. So what is x allowed to be? And there are some places where x has trouble being something. One of those places is inside of an even radical. The x in here, okay, the parenthesis has to be greater than or equal to 0. You can square root 0. You can fourth root 0. You can do 1, and you can do 2, and you can do 4, and you can do 10, but you can't do negatives. That gets us into the imaginary number set, and we don't want to be in there. We want to be in real numbers. So when you have an even root, your thing inside the root has to be greater than or equal to 0. Now that will shift as you add or subtract things or multiply by things in there by the x. Okay. Another place is down here in the denominator. The x has to not be 0. Or if we shift that around, it will change that up. But whatever is in the bottom, that bottom can't be equal to 0. So you set that equal to 0, solve. That's what x can't be. And we got log of x, where x has to be greater than 0. Not equal to, it won't touch 0. There's an asymptote there. Okay. So when we look at b, we're going to state when the expression is undefined. So we have to look for some of these domain issues to figure out where it's undefined. So do we see x inside of an even root? No. Do we see x in a denominator? Yes, I do. I see x is in a denominator here, and here, and here. Okay. And we want the original one before anything was canceled out, so I'm going to include the x plus 4. Okay, so if I say 2x is not allowed to be 0, and I divide by 2, x can't be 0. Okay, if I go x plus 4 is not allowed to be 0, and I subtract my 4, x can't be negative 4. And if I say x minus 1 can't be 0, and I add my 1 to both sides, x can't be 1. Those are my 3 places where x is undefined. Okay. I use a different method for that. I look at this thing and I use opposite to get out. Okay. So if I see a plus 4 in here, when I pop out of there, it's a negative 4. If I see a minus 1 in here, when I pop out of there, it's a positive 1. Since there is no plus or minus back there, the thing I'm plus or minusing is technically a 0, so I'd pop a 0 out of there. And I don't want 2 x's, I want 1 x, so I'd divide by 2. But 0 divided by 2 is just 0. So those are my places where I'm undefined. You'll have to watch out for those. You have to list them, especially ones that disappear. You may not list the 0. You may not list the 1. But you'd have to list x is not allowed to be negative 4. Because right here, you can't see that x is not allowed to be negative 4. But back over here, it had to be. Okay. So let's try an extra example. This one's not in your book, but we're going to go ahead and do it. If you want to pause really quick and try this one on your own first, you can. But we have a check problem for that here in just 1 second. So let's try another one. So we need to simplify x squared minus 36 over x squared minus 5x minus 66. So I'm going to factor that apart. The top one is a difference of squares. So I know that pattern. Square root of the first one in each. Square root of the second one in each. One's plus, one's minus. You can also think of that as x squared plus 0x minus 36. So factors of 36 that subtract to be 0. Now on the bottom, I'm going to go 2. Each one gets an x. Factors of 66 that subtract to be 5. Well, I got 1 and 66. I got 2 and 33. I got 3 and 22. Does 4 go? No. Does 5? No. 6 goes 11 times. Not 7, not 8, not 9, not 10, back to 11. So which one subtracts to 5? We got a winner here. So I got a 6, I got an 11. This one's negative, so it goes with my bigger. Okay, so when I simplify that down, I see that I have x plus 6's that cross out. So x minus 6 over x minus 11. And then when is it undefined? Well, back in the original, when I broke it apart before I crossed anything out, opposite to get out. X is not allowed to be negative 6. X is not allowed to be 11. Okay, so those are my answers there. Okay, we have a check problem here. Part A, it's actually multiple choice, but to know, you'd have to do the work. So go ahead and give it a pause, and then try this problem out. Figure out if it's A, B, C, or D, and state the domain. Be careful about that, especially when you get to the online book assignments. We're going to say list from least to greatest. Pay attention to how they tell you to list them, because it will be wrong if you put them in the wrong order. Okay, so give it a pause and give it a try. Okay, here we go. We got x squared plus 2x plus 1 over 4x squared plus 3x minus 1. Do my parentheses on top. Each one gets an x. Factors of 1 add to 2 would be 1 plus 1. So they're both positive. Now, oftentimes when you start doing these factorings, because you know they want you to do that, the top is a clue to what one of the bottom ones might be. So as we break this, I've only got x plus 1s in the top. So it's likely I'm going to get an x plus 1 in the bottom. Now this one's a little trickier because there's a 4 here and I can't factor it out. But factors of 1 are easy. I know it's a 1 and I know it's a 1. Back here it's a difference. So I know one of them's plus and one of them's minus. What matters is the thing in front. And so this is like, I'm showing you guess and check. We also know about slide and divide, and I'll show that in just a second as well. But I know it's a 1 and a 4, or a 2 and a 2, or a 4 and a 1. Like those are my order that I can put them in. So if I did 4x and x, that's negative 4x, that's positive 1. That would make a negative 3. So that's the wrong order. So if I did x and I did 4x, x times negative 1 is negative x. 1 times 4x is 4x, which would make 3x. That's the way I want it to be. So I know those are my parentheses. And then I know that this cancels that guy out. And so it's x plus 1 over x minus 4. Now, opposite to get out, x cannot be negative 1. And x cannot be a positive 1, but divided by 4. You want 1x, not 4x's. So you take that front number and you put it in the bottom, right? That one goes there. Opposite out there. So over here I would have negative 1 and 1/4. And 1/4 is also known as 0.25. Make sure you know those common fractions. Okay? And that's how that goes. Example 2, simplify by using a negative 1. Anytime you do a negative 1, it changes the sign of things. If you divide by a negative 1, it changes the sign of things. You multiply by a negative 1, it changes the sign of things. So factoring is dividing. It's pulling that multiplier out. So let's look at this problem here. We've got example 2, and we've got 6x squared minus 5xy, and we've got x plus 2y over x plus y times 5y minus 6x. Well, let's look at the ones we can factor. I notice that both of these have an x, so I can pull an x out. That leaves me with 6x minus 5y. And those guys don't have anything in common, so that stays. On the bottom, I've got these pieces here. Okay. So I've got that. And on this side, a 5y and a 6x, the numbers are the same. It's not the same letters, so it's just 5y minus 6x. Now we need to look at it and see if we have any matching pieces. Well, I'll go with a highlighter to show you. Okay, so we got an x and we got an x. We got a plus, we got a plus. We got a y, but then we got a 2y. So that's not a match, okay? They look close, but they're not exactly the same. We have a 6x, but it has a minus in front, and it doesn't have a minus in front. It's got a plus. This one's got a plus in front. This one's got a minus in front. And our samesies is 5y. So it's really close, but the signs are wrong. On the top, it's a positive 6x. On the bottom, it's a negative 6x. So what I can do is if I pull a negative 1 out of both of those, I can now say negative x. That's just like saying negative 1x. I've pulled the negative 1 out. That's going to switch my signs. That'll make that negative 6x plus 5y and x plus 2y over x plus y times 5y minus 6y. Now we're closer because I have this, see, I did it in green. It's a negative 6y and a negative 6. Oh, I changed the letters, didn't I? Yep, my bad. Changed my letters. It's supposed to be 5y, 6x. There we go. Get my highlighter back. So negative 6x matches. I have, it was in blue, positive 5y and a positive 5y. Now they're just in the wrong place, left to right. But you can add in any order you want. Remember, 2 plus 3 equals 5, and 3 plus 2 equals 5. That's the associative property. So I could flip these guys around. Give myself an equal sign. So negative x times 5y minus 6x times x plus 2y over x plus y times 5y minus 6x. And now I've got these matches. And so that is negative x times x plus 2y over x plus y. And I've gotten as simple as possible. Okay, that's how that one goes. Now let's look at our next problem. We've got another extra example. It's not in your book, but it is an example that you are allowed to do because I have it. If you don't want to do it, you get it, and you're ready to skip, then go ahead and skip on. Okay, I'm turning to the right page here in my book. Make sure we got everything going the way we need it to go. Very good. Which one is, oh, that's 9-2. There we go. Almost there. Okay. Awesome. So let's simplify by using a negative 1. Let's try this one. So we got another example. Let's get extra example. So 4x squared minus y squared over y minus 2x, 4 plus x. This is a difference of squares because 4 is like 2 squared. So I can say 2x plus a y and a 2x minus a y. Square root of the first, square root of the last, one's plus, one's minus, all over y minus 2x times 4 plus x. Well, again, I've got that same thing where the y and the y are in the wrong spot, and it'd probably be this one, right? One's positive, one's negative. And the 2 and the 2, and the problem is the minus is in the wrong place. Okay, they need to switch spots. Before I can switch their spots, I need to pull out that negative. So, and you can put it out in front of your parenthesis. You can put it out in front of the whole fraction. It doesn't really matter where it goes. But I'm going to leave it 2x plus y on this one. And this one becomes minus 2x plus y. And then I got y minus 2x on the bottom, plus, or y, 4 plus x there. And then I need to transpose those. So y minus 2x is what I really want to use. And I'll just write it up above like that because whoosh, whoosh, they're gone. And so I got negative times 2x plus y over 4 plus y. And that's my finish. And the domain is kind of an interesting deal because this one's got multiple variables inside it, so we don't really have to worry about that domain. But when we do have an x and when they ask or when we're solving, we do have to put that domain down. Okay, multiplying and dividing rational expressions. I think I might have missed a check in there. Let's add a page real quick. Boink. Here we go. We have a check opportunity here. I didn't get the page put in there, but I will for whenever I do it in class. So the check, it's on the page. It's on page 464. Okay. You can do it. It's not a problem. So simplify, select the simplified form of, and so we've got 7y minus 3x times 5x minus 1 over 5x to the third plus x squared times 3x minus 7. Okay. And then it does give you an A, B, C, D there in your book. I'm not going to list it. I'm just going to let you simplify this one out as a check for your knowledge, see if you got it. So give it a pause, try to simplify this down, and then come back and see what it is. Okay. In these two guys here, I see that they are in opposite places. So my trick is pull out a negative, and that will let me switch their places and their signs. 3x minus 7y. The negative 3x became positive. The positive 7y became negative. I switched their spots. I've got 5x minus 1. And let's see. Here we've got, let's see. There's shared x's, so I can pull out an x squared. That leaves me 5x plus 1. And I've got a 3x minus 7. That gets to go now. The 5x plus 1 and the 5x minus 1 don't get to go. They're not exactly the same. So we leave the 5x minus 1 on top with that negative. And then we've got an x squared times a 5x plus 1 on the bottom. And that's where we finish. And we could even say x is not allowed to be. The x squared doesn't have anything adding to it, so that's a 0. I do opposite the 1 and divide by 5. I do opposite the 7 and divide by 3. That's my domain. I'm not allowed to be those, in case they ask about it. Okay. Now, dividing. Okay. The method for multiplying and dividing fractions also works with rational expressions. You don't divide fractions. Don't divide fractions. Stay. Change. Flip. Stay the first fraction, change the sign to multiply, flip the other fraction over. That's how it works. Okay, you can see that down here. It was A divided by B divided by C divided by D. And then they changed it. Stayed A over B, changed to multiply, and then flipped C to D over. And then top times top, bottom times bottom. Okay, a complex fraction would look something like this. So A over B divided by C over D is the same as A over B divided by C over D. That just separates it. The top is there, the bottom is that one. And all you have to do is stay A over B, change the multiply, flip the other one over. And then you just top times top, bottom times bottom. So AD over BC. If they have any factors in common, get rid of them. So let's look at a couple. So we've got a multiply here. Okay, well, multiply, I guess I didn't go over that. I kind of thought we were doing that, but I didn't. But multiply is very easy. It's just top times top, bottom times bottom. Reduce. Okay, multiply is the easy one. Divide is weird because you don't. You turn it into a multiply. Stay, change, flip. So here's example 3. I'm going to do top times top, bottom times bottom. I'm going to show you this in 2 different ways. First one is multiply, then reduce. And then the second way I'll do it will be reduce, then multiply. So I'm going to go over into this space right here. Example 3. We've got 3x over 8y times 12x squared y over 9xy to the third. Okay. So 3 times 12 is 36. X times x squared is x to the third. You add the exponents. The y has no one to mess with, so it just hangs. 8 times 9 is 72. There is no x extra, so it's just x. And then y times y to the third is y to the fourth. Things that go into both of those. Let's see. 3 times 12 and 6 times 12. 12s go. 3 is 1 times 3. 6 is 2 times 3. So we can scratch out the, not the 2, scratch out the 3s. So we got, I don't have to put the 1, but I could put it 1/2. The x's, okay, the 3 is bigger. 3 minus 1 makes x squared. The y is bigger. The y is going to go to the bottom. 4 minus 1, because that's a 1, right? That was a 1. 4 minus 1 makes 3. I don't really need that 1, but I can leave it there. And it shrinks down to this guy. Okay. They do an expanded view of that in the book. Hopefully we're good and don't need that. But I will show you another way to work it. This is how I would work it. I reduce first. If you do a reduce first set, you're going to want to have some room on the top and the bottom to write in. Before I do the multiply top times top, bottom times bottom, I start getting rid of things that are in common. That multiply basically connects that line. So now I have a 3 in the top, and 9 is 3 times 3. So I can scratch that 3 out and scratch one of those 3s. 12 is 3 times 2, and 8 is 2 times 4. No, 12 is 3 times 4. There we go. Now this 3 and that 3 cancel. This 4 and that 4 cancels. And my 8 and my 9 and my 12 are all gone. I have a 2 that ends up in the bottom. Now I'll do my x's. This x and that x cancel, so I've got x squared left in the top. This y and that y cancel. And so I've got y to the third left in the bottom. Same answer. I reduce first instead of multiplying and then figuring out the big pieces, but it works the same either way you want to do it. All right. Example 3b, we've got 10d to the fifth over 6cd. Stay, change, flip, okay, because you don't divide, so I'm going to change it to multiply, and I'm going to flip it over. 4c goes on top, 30c to the third d squared now on the bottom. Okay, well, 10 goes into 30 3 times. 4 is 2 times 2. 6 is 2 times 3. There's a 2. There's a 2. Okay, I'm pretty well done with numbers. The 3's can't go because they're both in the bottom. So I have a 2 in the top still, and I got a 3 and a 3 in the bottom. So we do that. Let's do C cancels the C. So that leaves me C to the third in the bottom. 1D makes that down to 4. 2 more D's makes that down to 2. So I got D squared in the top. And so I should be pretty well set there. So 2D squared over 9 c to the third. Boom. Here's a couple of extra pieces to try. Pause now and give them a go. Okay, here we are. This one's already ready and set up. I'm just going to go right from where it is. The 6 is a 2 times 3. The 9 is a 3 times 3. The 10 is a 2 times 5. The 5 is a 5. 5s cancel. 3s cancel. So in the top, I got 2 times 2, which is 4. Let's see. I got this y and one of those, and this y and the whole set. I got this x and that x. So I've got x squared left over, carry the 3 across, 3y squared. Okay, stay the 27a squared b over a to the third, b to the third. I distributed those. Change the sign, flip it over, 2b squared, 18ab. 18 I'm going to do is 2 times 9. Now my 2's are gone. Let's see. 1, 2, 3 b's cancels b to the third. And then a is going to cancel one of those a's. 27 is 3 times 9. The 9 is going to cancel. And so I've got 3 and an a. So there's my 3. There's my a. I got a to the third, and I got a b. A to the third, b. I've got a at the top and the bottom, so I'm not done. That a is going to take that down to a squared. So it's 3a squared b. That's where you should be. Number 4, multiply and divide polynomial expressions. Hey, a word problem. Geometry style. A manufacturer that creates and sells rectangular planters wants to compare the areas of the top sections of 2 potential sizes of planters. For some given measure x, find the area for the first planter. The area for the first planter is represented by this. Great. And the area for the second planter is represented by that. Great. Write and simplify an expression that represents the ratio of the area of the first to that of the second. So we're going to do first as a ratio to second. So the first is x squared plus 15x plus 50 over x plus 2 over x squared plus 30x plus 200 over x plus 2. Stay, and as I stay, I'm going to break it up. So each one gets an x. Factors of, that's supposed to be a 50. 50 that add to be 15 would be 5 times 10. They're both plus. Change it to multiply, then flip it over. The x plus 2 goes on top now. And I'm going to factor this bottom section, which gives me an x in each. And factors of 200 that add to 30. Let's see. Well, 200 is made out of 20 times 10. Hey, look, that adds to 30. 20, 10. X plus 2's cancel. X plus 10's cancel. And so x plus 5 over x plus 20. X can't be, now worry about your original and your flippage. So originally in the bottom, x couldn't be negative 2. But then when we flipped over, we got a 20 and a 10 down there. So it can't be negative 20 and it can't be negative 10. This is what we're looking for, but you need to know about that domain. And whenever it's a division problem, you have to think about where it started with divisions and where it went with flipping overs for your final answer. Okay, so be careful. Watch those ones that disappear. Multiply and divide polynomial expressions. Geometry. So here's an extra example. Consider the rectangle of an area this. If the rectangle were one face of a rectangular prism with depth of that. Write and simplify an expression to represent the volume of the prism. Okay, so the area is all of this stuff. And volume is take that area surface thing and then stretch it backwards this way. So it's just side times side times side. We have two sides. This is area equals side times side, right? Or length times width. And volume is going to be length times width times depth or height, whatever way you want to call it. They use the word depth here. So we just have to multiply these. So we have to do x squared plus 5x plus 6 over x plus 1 times x squared plus 4x plus 3 over x plus 2. That's supposed to be a 2. Factor them. X. Factors of 6 add to 5 are 2 and 3, both positive. X plus 1. And we'll do times, and we got an x plus 2 down here. Each one gets an x. Factors of 3 that add to 4, well, it's just 3 and 1, and they both add to 4. Okay, so x plus 2 goes, x plus 1 goes, and we've got x plus 3 times itself. So we got x plus 3 squared, or x squared plus 6x plus 9. Okay, but remember, x can't be -1, -2. So there's our actual expression. This is our domain piece. Okay. And then they go into complex fractions. And all that is this means 3x over x minus y divided by 6xy over 4x squared minus 4y squared. That's all that complex fraction thing means. And we know what to do. We don't divide. We stay, we change, and we flip it over. As we flip it over, I'm going to factor. These both have a 4, and they are squared things minusing. So I'm going to pull the 4 out front, and I'm going to say x plus y, x minus y. Okay? Because this is actually 4 times x squared minus y squared. We could write it right there. That's the thing that breaks up. So we get to cut out the x minus y's. 4 is a 2 times 2. 6 is a 2 times 3. I can get rid of the 2's. I can get rid of the 3's. I got an x down here and an x down there. So my leftovers are a 2 and an x plus y. And my other leftover is just a y. Just like that. That was fast. Pause it, rewind it, slow it down. But by the end of the year, we should be crushing on these. Okay. 3x minus 9 over x plus 2 times x plus 2. That's what it means to be squared. I'm writing both because I like to be able to cross them out a little easier. Multiply, and then we're going to flip it over. 3 minus x goes down here, and I'm going to factor this bottom one. Each one gets an x. Factors of 24 that add to 14 would be 12 and 2, and they're both plus. Now, in here, I got 3's each, and if I notice, the 3's match. The x's are on the wrong. The x has a positive on the top, right? This one's a positive. That one's a negative. We want that to switch. So I'm going to pull out a -3. Take a -3 out of a -9. You're left with a +3. Ooh, and I'm going to put it in the front. And take a -3 out of a +3x. That's going to change it to a -x. If you put it back in, negative makes +3x. Negative times positive makes -9. Okay, so that's where I got those. So now I can cross that off. Oh, that's supposed to be a plus. Good. There's my catch on my math because 12 plus 2 is 14. I don't want to minus. That'd be 10. And I knew it had to be a match because they want me to get rid of stuff. Okay, so things I got left over. I got a -3. I got an x plus 12. And I got an x plus 2. X can't be. Let's think about where it was originally. It can't be -2. Can't be -12. And then we moved it to the bottom. If we did 3 minus x equals 0, added x. x can't be 3. Those are a thing. This is what I'm looking for the most, the simplification. But think about that domain. What can't it be? Okay, what can it not be? And then it's time to check yourself. Pause, give this problem a go, and then come back and see what it is. Okay, here we go. Last one of this section. That's 3 squared. So that is x plus 3y times x minus 3y over xy. Change it to multiply. I got x squared on the top now, and then these both have a 2, so I got 2 times x plus 3y. X plus 3y's go. That x cancels this down to just an x. And I've got x times x minus 3y over, I got a 2 and I got a y, so 2y. And since it's double variable, you don't really have to put the domain part on it, just simplifying that piece. And that's multiplying and dividing. Okay, simplify, take off those factors they have together. Multiply, top times top, bottom times bottom, reduce, or reduce, like factor apart, reduce, then multiply. Divide, don't. Stay, change, flip. Now it's a multiply. Do it just like a multiply problem. Good luck.